All, welcome to the session on antenna aperture. Now, when you consider any types of antennas like parabolic antennas or the horn antennas, it has a aperture, wide aperture, and the antennas will be receiving electromagnetic radiation. Maybe it is a transmitting antenna or maybe it's a receiving antenna. But based on that, it will be receiving the electromagnetic radiation. Now, when you consider the aperture, basically it is the area over which, now when you consider this parabolic antenna or the horn antenna, it's the area through which it is either receiving or transmitting the electromagnetic energy. So we can define the aperture as the area through which the power is radiated or received, and based on the type of radiation or the losses which is happening across the antenna, we have different types of apertures. Now, when you consider an horn antenna, it is the here you can see the horn antenna where here this is the horn antenna and this is the area through which it would be receiving the electromagnetic radiation. Now suppose you consider the Poynting vector or the power density. So power density is the power flow per square meter for the incident wave. So you can just assume that this is the direction of propagation of the plane wave, and let Poynting vector be given as S, so which is the watts per square meter, and the area of the mouth of the horn can be considered as A. So if the on is this on antenna is extracting all the power because this is the area and through this electromagnetic radiations is coming up, and just consider that this is the area over which all the power is being extracted or it has been absorbed. So if you consider the power absorbed from the wave as P, then the power can be written as S into A, because S is the Poynting vector or the power density and A is the area over which the horn antenna, the entire power is entering. Now, this is how the power absorbed can be written, and the unit will be watts because it is mainly like basis of the power that is getting received, and also A is the aperture or the effective area, or you can mention it as the capture area, and S is the Poynting vector of the incident plane wave. Now, based on the type of aperture, so when you consider aperture based on the type of losses, now there can be radiation losses, scattering losses. So there are different losses which could be occurring across the antenna. Based on that, there are several types of apertures like effective aperture, then the scattering aperture, loss aperture, and then the collecting aperture. So this is mainly based on the losses and the radiation resistance of the antenna. You have different types of apertures. Similarly, you also have the concept of physical aperture. So physical aperture is nothing but the physical structure of the antenna based on that, or the actual physical size of the antenna. If you consider the antenna, this is the physical size of the antenna. Now, if you consider the complete physical size of the antenna, based on that, the aperture that you consider, you can consider it as the physical aperture. But effective means even though the physical size is this much, effectively across the complete physical size, the electromagnetic radiations will not be transmitted or received. So that's why you have different types of aperture. But physical aperture is based on the size of the antenna or the actual size of the antenna, the aperture what you get, that we can call it as the physical aperture. So again, this is the area through which the antenna is receiving, the power is radiated or received. Mainly, if you consider any effective aperture, that would be around 50% of the actual physical aperture. So always the physical aperture would be much more less compared to the actual physical aperture of the antenna. And we can represent the physical aperture as AP. Now, if you consider if there are no losses, so as I mentioned, even though this is the physical size of the antenna, effectively through the complete physical size of the antenna, the power will not be radiated or received. But suppose you assume that there are no losses. So there are no losses means effective and the physical aperture would be the same. So if there is no losses, then in that cases, we can assume that the physical aperture is equivalent to the effective aperture. Or this is when you will be having the maximum directivity. So whenever we mention about the maximum directivity, that is when there is no losses, or it's like the ideal situation where there are no losses, but which is not possible. But in such cases, we can assume that the physical aperture is equal to the effective aperture. And of course, the directivity is given by the formula 4 pi by lambda square into AE. Similarly, if you are considering the maximum directivity, you could write this as 4 pi by lambda square into the physical aperture. Now, this is how you receive the directivity maximum. And there is also the concept of absorption ratio. The absorption ratio, if you consider, this is equal to the ratio of the maximum effective aperture to the physical aperture. So this can be written as the maximum effective aperture divided by the physical aperture, and the absorption ratio is usually denoted by gamma, and the value will be between 0 and infinity, and as it is a ratio there is no unit. And this is possible like whenever we assume that there are no losses, that's when this concepts comes into picture. But as such, if you see none of the antennas, you can assume, you can see that always any kind of antennas you consider, there will be losses. And based on that, there will be different types of apertures as well. Now, in the next video, we will start discussing about the different types of apertures. So do like, share and subscribe to the channel. You can see more videos in the coming lectures.